So back in elementary, we learned about combining fractions. And the one rule was making sure that our denominators were the same. So if you had something like 1/3 plus 1/3, you would combine them by just adding their denominator, or their numerators, excuse me. So it'd be 1 plus 1, which is 2, over 3. And if possible, let's say we had like 1/6 plus 1/6. This would be 2/6. And from here, we could actually take it a step further by reducing this and making it 1/3. So this was the concepts that you guys learned back in elementary, and it can be applied to our polynomial or rational expressions. So the first thing we're going to check is make sure that our denominators are the same, and they are, in fact. So I'm just going to go ahead and combine my numerators. That's going to give me 3 plus 5, which is 8, over 2x. And then at this point, I can see that I can, in fact, reduce 8 and 2. 2 goes into both of those, making the 8 4, and the 2 a 1. And so this can be reduced and say 4 over x. And this is our answer. The same thing can be done for letter B on the right-hand side. Just note that there is a subtraction sign. And personally, I find the easiest thing to do is to change that subtraction to a plus sign and then switch all the signs in the second numerator. So it's not going to say negative b plus 2. All right, again, our denominators are the same, so we're just going to carry that denominator over. Please note, I'm not like multiplying my 9s. I'm not adding my 45s. They are the same type, and so I need to keep the same type into my new compiled fraction, if you will. So I brought over that 9b plus 45, and now I'm going to combine my numerators, and I actually have some like terms that I can combine. So I have that 5b right there, but I also have this negative 2 and this positive 2. And so if I combine that, it's going to give me a 4b, and the 2's actually end up canceling out. So I am almost done, but make sure whenever you are done with adding or subtracting a fraction that you always ask yourself, is there anything to reduce? Like over on the left-hand side with part A, we were able to reduce 8 over 2. Another thing you can ask yourself, is there anything that I can factor? And in fact, I can actually factor something in the denominator right here. So I'm going to go ahead and factor out a 9. So my answer is going to be 4b over, factor out that 9, and we get b plus 5. And this is our final answer because we can't do anything else. I can't cancel out like the 4 and the 9 because they don't have any, common factors. So this is going to be our final answer, and this is how the book would like you to write your answer. So example 1.1 on the left-hand side, again, our denominators are the same, so we're just going to carry that denominator over and combine our numerators. Notice we do have a minus sign, so it's going to be 8 minus 5, which is 3, and I can reduce that to be 1 over 4x. All right. The other letter B on the right-hand side, we're going to do this one off to the right, is not like terms, and so we're going to end up sticking the numerators next to each other over that x plus 1. Again, notice I'm not doing anything to this x or this x. It's the same type of denominator, and that's the same type of denominator that needs to end up in my final answer. So before I box in my answer, I just have to ask myself, is there anything that I can factor out? And the answer is no. I don't have a GCF, and unfortunately, think about this as a family. This is 9 minus 2x, and this is x plus 1. They're a family. It's a unit. So I can't actually, even though there's an x here and x here, I can't cross them out because it's not just x. It's 9 minus 2x. It's not just x. It has, friends and family. It's a unit. And so I can't actually just cross those out and be like, yay, I did it. You cannot. Please don't do that. It makes me very sad. So this is actually my final answer. I wasn't able to reduce anything, and that's okay. That happens. The one underneath that, 5x plus 15, this one I'm going to actually cram my work in, but it'll be fine. Again, I don't have any like terms, so it's going to be 5x plus 15 over x plus 3. All right, and I can ask myself, okay, is there anything I can factor out? And I can in the numerator. I can factor out a 5 and get x plus 3 over x plus 3. So remember, the denominator is a unit, x plus 3, and I have x plus 3 in the numerator. And this is going back to 7-3, where if we had the same exact thing, we were able to cross it out. So this x minus 3 is going to cancel out with that x minus 3. And for this one, my answer is actually going to be 5. And that is it. All right, so hopefully that is not super difficult for you. And so let's move on to the example 2, where our denominators are not actually going to be the same. So again, back in elementary, when we had two fractions that were not the same, what we had to do was we had to find the least common multiple. And the least common multiple was just a number that we could, that was in common with our denominators, in this case 3 and 4, and we could go ahead and try to multiply each denominator to get to that least common multiple. So I could pick something large, but I'm gonna try to pick something smaller. 12 is the LCM for 3 and 4. It's very simple for this one because you're just multiplying 3 times 4. Back in elementary, you did like factor trees, and then you counted your factors, and that's too much. We're not going to do that. So on the left-hand side, I can multiply my 3 by a 4. And just remember, whatever you do to the bottom, you have to do to the top. Because technically this is 4 over 4 or 1, and you're allowed to multiply anything by 1. That's one of the rules in math. So on the right-hand side, I'm going to multiply it by 3, and again, what I do to the bottom, I do to the top. And so I end up with 4 over 12 plus 3 over 12. And now my denominators are the same, so I can go ahead and combine those numerators. I get 7 over 12, and that is our final answer. And of course, if I was able to reduce that, then that's great, but that's not always the case. So I'm going to skip around a little bit. We're going to start off with a pretty easy one, very similar to the example we just did, and that is going to be this example 2.1a on the left-hand side. I have 4x in my denominator, and I do not have a 4x or anything similar to a 4x on the right-hand side with that 7. So I need to multiply that 7 by 4x. What I do to the bottom, I got to do to the top. On the left-hand side, I have that 4x, but I don't have a 7, so I need to multiply this side by 7, and again, what I do to one side, I do to the other. And so what I like to do when I start this is I say, okay, well, my original numerator was 3, okay, and I multiplied that by 7. All right, and then I have this minus sign, so I'm just going to carry this minus sign here. My original numerator for the second fraction was 1, and then I multiplied that by 4x. And this is just an easy way to make sure that I have brought everything over and that I'm just doing it correctly. Now, to write my denominator, just ask yourself, well, what is 4x times 7? Well, it's going to be 28x. And if you did it for the other one, it's going to be the same exact thing, 28x. So we know we did it correctly. All right, so I'm going to go ahead and finish the numerator. I have 3 times 7, which is 21, and negative 1 times 4x, which is negative 4x. Now, I really don't feel like rewriting my LCM a bajillion and a half times, so I'm just going to write LCM until I'm ready to write my final answer. But just know that this LCM annotation is the same exact thing as 28x. I just don't want to write it again. All right, so before I write my final answer, I just want to ask myself 21 and negative 4. Is there any sort of GCF I can factor out, or is there like the X method I can do? And the answer is no. So I just need to make sure it's written in standard form. That's when your X goes first and your constant goes last. And so at this point, I can't do anything else. So I think I'm ready to put that 28x back. And this is my final answer. Again, please make sure you remember that this is not just x right here. These are not just x's. I mean, it is on the bottom, but it's not on the top. This is a unit right here. Negative 4x plus 21. That is a unit. We can't just randomly take out an x for kicks and giggles. That's not allowed. But this is my final answer. And so hopefully that's a good way to start. So let's go over to example 2.2a on the right-hand side. All right, again, the common mistake here is that people are just like, oh, 4 and 6, the LCM of that is 12. Well, it's not 4 and 6. This is x plus 4. This is x plus 6. And so I actually need to multiply by the unit, not the number, the unit that it's attached to. So my first fraction has the x plus 4, but my second fraction does not. So I need to multiply this side, top and bottom, by x plus 4. And then the right-hand side has that x plus 6, but the left side does not. So again, I'm going to multiply the left-hand fraction by x plus 6, top and bottom. So my LCM is just going to be one of these, all right? We're not going to write x plus 4 times x plus 4 times x plus 6 times x plus 6. That's not what we're doing. We're just taking one of them. And so that's going to be x plus 4 times x plus 6. And if you want to switch that, x plus 6 times x plus 4, that's fine. It doesn't really matter, but this is my LCM. All right, my numerator is going to be that 3, because that was my original numerator, and I multiplied that with x plus 6. Carry the minus sign, and my original numerator was 1 times x plus 4. All right, so now I can do the distributive property. I can do the distributive property here and here, and I should get 3x plus 18 minus x minus 4, all of that over the LCM. I can combine like terms in my numerator. That's going to give me a 2x plus 14 over that LCM, okay? And then in addition to that, I can actually factor out a 2 between the 2 and the 14. So if I factor out a 2, that's going to give me x, and then 14 divided by 2 is going to give me 7. All right, so I think I'm ready to put my LCM back, so I'm going to carry that over. And if I did have the same, like let's say this was a 6, if I did have the same, I would be able to cancel those out, but I don't, and so this is actually my final answer, and I can't really do anything else. All right, let's move on to another one. Let's actually go up to the top where we skipped originally. This was my first example in class, and some people, they really were like, oh, okay, I get it, and some people were not, so we're just gonna tackle it now. Okay, so my first fraction is 9x squared, and so I'm actually going to rewrite this. I'm going to rewrite that as, 9 can be rewritten as 3 times 3, and x can be rewritten as x times x. So I've got that, and now I'm going to factor my GCF out of my second fraction. The GCF is 3x, and that'll give me x plus 1. I'm going to cross it out so I don't think that's related anymore. I've gone ahead and factored it, so we're good. All right, now, here's another common issue. People are like, oh, well, I see a 3 and a 3 there, so I'm done. Well, actually, we don't see just one 3. We see 2 3s. So I need to multiply the right-hand side by another 3, top and bottom. Same thing happens with the x's. They say, oh, I see an x here and an x here. And then some people even go, oh, here's an x here and an x there. But remember, this is not x. This is x plus 1. It's different. It's a unit. So we are going to actually need to multiply the right-hand side by an x as well. And now I have 2 x's and 2 3's on each side. All right, but on top of that, I do have that x plus 1 on the right-hand side, and I don't have it on the left. So I'm going to go ahead and multiply this side by x plus 1. And then what you do to one side, remember you do to the other. Okay, so it looks like I've been able to get the same exact number of items, we call them factors, the same exact number of factors on each side of my fraction. So I'm going to go ahead and rewrite it. It's going to say 7 times x plus 1 for that numerator, the blue being what was originally there, the purple being what we multiplied, plus x times 3x. All right, all of that over my LCM, which is 2 3's, which is 3 times 3 or 9, x times x, which is x squared, and x plus 1. All right, this is my LCM right here. I'm going to do the distributive property in the numerator, and I guess I'm going to do the distributive property for that second one, but really it's just, they're all monomials, so I can just multiply them. But I should get 7x plus 7 plus 3x squared, all of that over the LCM. I have a little bit more work to do because I need to make sure it's in standard form. So it's going to be 3x squared plus 7x plus 7. And if I tried to do my slide and divide here, it actually would not work. So this is infactorable. So I think I'm ready for my my LCM. So I'm going to carry this down, 9x squared times x plus 1. Again, note, this is not just 3 and just 9. It is just 9, but it's not just 3. It's also not just an x squared. This is actually 3x squared plus 7x plus 7. It is a unit. So I put parentheses around it, again, to represent that it's a unit. If you try to plug that into the Big Ideas Math website, it's not going to accept it because it's confused as to why you're putting parentheses around it. But for sake of visual help, I put parentheses around it so that I remember it's a unit and I cannot cancel things out unless I have the exact same unit, and I don't have that. All right, so let's go off to the bottom again, back to the example 2.1, letter B. It's very, very similar to what we did, but I just want to make sure we've got more practice. Some people get really thrown off if it's like even slightly complicated, and not that that's a terrible thing. It's just part of practice, but I just want to make sure we've got this under our belt. So if I factor out the first one, 3 I can't do anything with, but x squared I can make x times x, so I can cross that out. My right hand side, I actually have a GCF, and that's the only thing I can do. It was almost a perfect, not a perfect square, but a difference of squares, but it didn't work out because I have that 3 that I have right here, but that's fine. All right, so I see a 3 in both of these, so I'm good there. I have 2 x's here, and I don't have 2 x's on the other side. Remember, I do have this 3x squared minus 4, but that is a unit. So even though there is an x squared in there, it's not actually there because it's 3x squared. So I'm going to do 2 x's, top and bottom, and then again, I have my unit, 3x squared minus 4, and I need to multiply that on the left-hand side because the left-hand side is missing it. 3x squared minus 4. So it's a little cramped, but we should be fine. And so my numerator is going to say 1 times, hopefully I have enough room to fit this, 3x squared minus 4, and then plus x times x squared. All of that is going to be over. So note I just carried it over this way because it was a little cramped. Sorry about that. All of that over 3. I have 2 x's, so that's x squared, times the unit, 3x squared minus 4. Okay, I can do the distributive property. Anything times 1 is itself, so I'm just going to make this a 3x squared minus 4 plus x cubed, all of that over the LCM, which is this portion right here. And I just need to make sure it is in standard form, and it is not, so I'm going to put that 3x cubed first, followed by that 3x squared minus 4 over, and I think I'm ready for my LCM, so it's 3x squared times 3x squared minus 4. And I'm not going to do any distributive property in the denominator because they don't want me to. I'm just going to keep that monomial in front of the parentheses, and make sure you do that on the homework as well. Like if you have a 2 in front of parentheses, don't distribute. They do not want you to. Even if you have 2 binomials, do not multiply them. They want you to keep it completely factored. All right, so that is with a monomial and a binomial. So let's do one, it's a little bit, I'm going to say it's harder. I would just say it's just a little bit different. We've got a factor with our x factor now. So if we look on the B on the right-hand side, I'm going to factor my x squared plus 5x minus 24. If I factor that, that's going to give me x plus 8 and x minus 3. So I can cross that out. And on the right-hand side, I actually have that x minus 3 already, but I'm just missing the x plus 8. So I'm going to go ahead and multiply that side with x plus 8. What I do to the bottom, I do to the top. And so I actually don't have to do anything else. I only had to multiply by one thing this time, which is very nice because sometimes it gets really long and complicated. So my numerator is going to say 12 plus 3 times x plus 8, all of that over my LCM, which is x plus 8 times x minus 3. This is my LCM. I can do the distributive property in the numerator with that 3 right there. That's going to give me a 12 plus 3x plus 24, all of that over the LCM. Combine like terms. Combine like terms and we get 3x plus 36 over the LCM. I can actually do something else. I can factor out the 3 here and get x plus 12, all of that over. I think I'm ready for my LCM. X plus 8 times x minus 3. And this is my final answer. Again, please do not try to cancel these 3's out, because even though it is just 3 right there, it is not just a 3 down here. This is x minus 3. So you need to make sure that you're not accidentally crossing things out that you're not supposed to. All right, last one. We're actually going to go back up to the top. I really like this problem, to be honest. It is a really good problem. There's a lot of things that we can do with it, and it's just it just has a lot. It really encompasses a lot of different skills. So again, we need to factor. I have a GCF right here. It gives me 2 times x minus 1. And I have a minus in between, and I can easily fix that by changing a positive and flipping the signs of the numerator, which I do want to do because I have a binomial and I just don't want to think about it later. Factoring the denominator of the second fraction gives me an x minus 3. Can barely see that, so let me make it bigger. X minus 3, x minus 1. And now I can see that I have x minus 1 in both of my fractions, but I'm missing a 2 on this side. What I do to the bottom, got to do to the top. And I'm actually missing an x minus 3 on the left-hand side, x minus 3. Okay, so my numerator is going to say x plus 2, that's the original, and I multiplied that by x minus 3. And remember that the 2 that you see right there is from the other problem. Just want to make sure you don't think that's multiplying by 2 as well. All right, plus, and I multiplied the other numerator by a 2. Hold on, let me actually do the same format as I've been doing. So it's 2x plus 1. That's the original of what I had, and I'm multiplying it by 2. All of that over my LCM, which is 2 times x minus 1 times x minus 3. Remember, we're only taking one of them, all right? It should be the same no matter what. So it doesn't matter if you pick that one or if you pick this one. It should be exactly the same when you bring it over. All right, so this is going to be my LCM, so I'm just going to stop writing that for now. And let me actually erase this right there. Okay. And so my numerator, this is actually going to be FOIL. Oops, this is going to be FOIL. Is going to be FOIL. So if I FOIL that, it's going to give me x squared minus x minus 6 plus, and then technically this is the distributive property. So it's going to say 4x plus 2. I can combine my like terms here, and I can get, I'm actually going to write this over off to the left, x squared. Cross that off. I have a negative x and a 4x. It's going to give me a positive 3x. And I have negative 6 and positive 2, which gives me a negative 4. Again, all of that over that LCM, but I'm just going to not write that either because I'm running out of room. And I can actually factor this trinomial. This trinomial is going to give me x plus 4 and x minus 1. Again, I can't do anything at this point, so I guess I am going to bring my LCM down. It's going to be 2 times x minus 1, x minus 3. So I do actually have something I can cancel out. I have this x minus 1 and this x minus 1. Notice that I'm crossing out the entire unit, not just the x and not just the negative 1. The entire unit was crossed out at the same time because it's a unit. All right, so that means I'm left with x plus 4 in the numerator, and then 2 times x minus 3 in the denominator. And I cannot do anything else. So this is my final answer. So I really do like this one. It just has a lot, and I understand it is a lot, but it is a really good problem because it just has so many things that you can do, and it just shows that you can really work at it and get a really small fraction if the numbers are right. All right, so if you are a standard student, at this point you can stop the video. But if you are honors, you are going to have to stay for example 3. So this is known as a complex fraction. It's a complicated fraction on top of a complicated fraction. Or really, it's a fraction in the numerator and a fraction in the denominator, but it's whatever. Anyway, so what your goal for a complex fraction is to make your denominators the same. So, or to have one whole fraction in the numerator and one whole fraction in the denominator. To do that, I'm going to need to multiply my denominator to make them the same. So I can make this 3, or I can multiply this 3 by a 2. What you do to the bottom, you do to the top. And I can make it so that it is in fact a 6. So this will be x minus 2x over 6. All right, so I have completely made one fraction for my numerator. I'm going to carry this fraction bar over. And now I'm going to do the exact same thing for my denominator. I have 5 and 10. I can multiply the 5 by 2. What you do to the bottom, you do to the top. And I can make it 2x minus 7 over 10. Once you are completely done making one fraction on top of one fraction, you want to do keep, change, and then flip. And we're going to write it like we did back in 7-3 because it's just so much easier. So I'm going to take that first fraction, and actually I can combine that. It can be negative x. So let me negative x over 6 times 10 over 2x minus 7. All right. At this point, I don't have any like addition signs or subtraction signs, so I don't have to worry about the same denominators. I just need to see what I can cross out that is on top of each other or diagonal of each other. For example, I have this 10 and 6. They're both divisible by 2, so it would give me 5 and 3. I cannot see anything else I can do, and so my numerator will end up being negative 5x over 3 times 2x minus 7. And I cannot do anything else, so this is my final answer. So it looks a little bit more complicated than you might think, but it's actually very straightforward. All right, so let's say we had example 3.2. My numerator is already done, so I just need to focus on my denominator. So remember, these are units, and my left fraction is missing the x plus 5. All right, so x plus 5. My right fraction is missing that x minus 3. X minus 3. So my numerator is going to end up, actually, let me put parentheses right there. All right, there we go. My numerator, and remember, we're just ignoring the top for a little bit. My numerator is going to be 2 times x plus 5 plus 1 times x minus 3. All of that over the x minus 3 times x plus 5. Because remember, we just took one of them. This is my LCM of the denominator. Okay, so I can do my distributive property here. Boom, 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 boom. And I should end up with 2x plus 10 plus x minus 3. All of that over that LCM. And then I can continue further by adding my like terms. This is going to give me, I'm going to put my little equal sign right here. This is going to give me 3x plus 7 over x minus 3, x plus 5, because I cannot do anything else, so I'm just going to carry that LCM down. All right, so this is my one fraction in the denominator, and now I can focus on that numerator. This is the one fraction of the numerator, so this is going to be my keep. Of course, I'm going to change, and this will be my flip. So I'll rewrite it, 3 over x plus 5 times x minus 3 times x plus 5 over 3x plus 7. All right, again, I recommend putting parentheses around your binomials so that you remember they are units. You can't just randomly cross things off for kicks and giggles. You have to only be able to cross things off if they are a complete, exactly the same unit. So I have x plus 5 and x plus 5. That is the exact same unit. And so my numerator is left with, I don't know where that negative came from, 3 times x minus 3 over 3x plus 7. If you even dare to cross this 3 out with this 3, You are wrong. Please do not do that. It is not okay. Remember, the x or 3x plus 7 right here is a unit. You can't just randomly get rid of the 3 because it is not the exact same unit as this 3. This is 3x plus 7. This is 3. They are different units. So we're going to leave them alone, and this is our final answer. Hope that's been helpful. If you have any questions, make sure you email me.